Design Project Safety, Assignment 17.
Hi, I'm Isabel Agner. I plan on going into chemical engineering, and I like to play and listen to music and also play with my dog.
Hi, I'm Pinto. I'm from Chicago, Illinois. I want to go to biomedical engineering, and some of my interests are listening to music, surfing, and playing volleyball and soccer.
I'm Ashton Shipley. I'm from Helena, Montana. My intended major is aerospace engineering, and I really enjoy skiing, hiking, sports, and music.
Hey everyone, my name is Jake. I'm from Miami, Florida. I intend to go into ECE, and some of my interests are golf, listening to music, and things that involve the ocean and the beach.
Our student-led engineering group recognizes the growing danger of personal transportation and pedestrian accidents on Purdue's campus. Purdue University, our client, has requested an effective solution to this problem. We acknowledge that the unpredictable weather of the Midwest requires that this solution is durable for all temperatures and weather conditions. This will benefit the students, faculty, staff, and locals on Purdue's campus. It is important to us that travel between classes is safe for all residents of Purdue University and the greater West Lafayette area.
Our team decided to prototype the 3 designs we felt best accomplished the goals for this project. With this being said, we created prototypes for the traffic tracker, soft safety, and the cyclist urban radar and tracking information system, or CURTIS for short. Traffic tracker is similar to a walk sign at a road intersection, however we would implement it at bike lanes. Soft safety is a soft line of lights and pressure plates that light up the whole road when a bike goes over it. And finally, CURTIS is a small sensory box that tracks vehicle users in real time, calculating their position, velocity, and direction. With this information, CURTIS is then able to calculate at what points it is safe for pedestrians to walk across the bike lane. We then went on to test these designs to make sure they met the criteria and constraints of this project. 2 main things we tested for were how well each device was able to detect moving traffic and at what ranges each prototype could detect moving traffic. We also tested for durability, logging how many times a prototype malfunctioned during each testing period. From our tests, we were able to determine that CURTIS was the best design to meet the needs of the criteria. As seen in the data, CURTIS had a 98% accuracy rating when testing its reliability at fixed distances. In comparison, Traffic Tracker had a 96% accuracy and Soft Safety had a 92% accuracy. In regards to object recognition, CURTIS yet again showed the best performance with a success rate of 98%, whereas Traffic Tracker had a 90% rating and Soft Safety had an 84% rating. Given the data from our testing, our team determined that CURTIS was the optimal prototype to take into the final design stage of this
We
project.
found that CURTIS showed to be the best prototype with a 98% accuracy rate. Through our weighted decision matrix, we determined that CURTIS was the best when considering affordability, efficiency, effectiveness, and durability. The purpose of CURTIS is to alert pedestrians throughout campus that there is a moving vehicle in the bike lane. CURTIS works by utilizing a TI kit, distance sensor, and buzzer. When CURTIS registers that there is a moving object, it will make a buzzing sound to alert pedestrians.
All right, and going into design trade-offs and limitations, obviously not every design is going to be perfect, especially with the limited time and resources that we have. So jumping into trade-offs, as of right now, we don't have any backplating, and this was to allow us to take out and put in the TI kit and allow for tweaking and stuff, so we can improve it. So right now we don't have that part. There's no sound component yet because we were just focusing on visuals throughout the entire design process. We were planning on a sound component, but at this time we just didn't have the time for it. And another thing is with the metal, we sacrificed how it looks with durability and the low cost because the metal is obviously cheap and it's going to be able to withstand a lot. And we thought that that was more important than how it looks as of right now. And then going into limitations, obviously it's only going to be able to be as effective as the sensor that it has in it. So if it doesn't have that great of a sensor, then it can only do so much. And another thing, it's at the discretion of the pedestrians if they want to walk. So if they're distracted or they see someone and walk anyways, we can't really do anything about that because there's not a physical barrier stopping them from walking. And another thing, the visual components, it's done by a TI kit, so we don't get the speed and the time like we really wanted. So with the TI kit, we are kind of limited by that. But in the future, we do plan on improving that if we were to launch this as a full-on solution. And at the end of the day, we think that this is still a really solid solution and we want to use it in the future.